In this video, I want to go over the sum of digits digital root problem on Codewars. And what I want you to do is, given n, take the sum of the digits of n. If that value has more than one digit, continue reducing in this way until a single digit number is produced. The input will be a non-negative integer. So the argument that they pass us is going to be called n. Let's look at some examples. For example 1, n is 16. What they want us to do is, if n is a single digit integer, return it. However, if it is a multi-digit integer, we need to sum up the individual digits in that integer. So, since it is a two-digit integer, we need to sum it up. 1 plus 6 is equal to 7. 7 is a single digit integer, so we return 7. 942 is a triple digit integer. We add 9 plus 4 plus 2 was 15. 15 is a double digit integer, so what we need to do is sum up the individual digits. 1 plus 5 is equal to 6. 6 is a single digit integer, so we can return it. We do the same thing on these bigger integers, but I'm not going to do it for you. So the way we're going to try to do this is actually kind of unique. We're going to do it recursively in a ternary operator in a single line of code. So, just to make it interesting, let's just try this out. So when do we want to return n? We want to return n when n is a single digit integer. When is n a single digit integer? Well, when it is less than 10, right? 1 is a single digit integer, 9 is a single digit integer. So we can return n if and only if n is less than or equal to 9, right? Well, what happens if this test condition isn't true? What if n is not less than or equal to 9? That means that it's greater than or equal to 9. Well, if it's greater than or equal to 9, that means it is a multi-digit integer. So what do we do to multi-digit integers? We need to sum up the individual digits, correct? Well, there is a special function in Python that will allow us to do this called the sum function. However, this sum function requires the argument to be passed to it to be an iterable. N is an integer. Integers are not iterable. So we need to somehow convert n into something that is iterable so we can then pass it to our sum function. Well, one thought for me anyways is a list of integers, each element being a digit of that integer. So we can actually do this using list comprehension, and I'll explain it after I type it. But we can say int I for I in string n. So what is this doing? Well, I'm sure you know what a for loop is. For I in string n, we are first converting n into a string using typecasting. The reason being is because we cannot iterate throughout this integer n as an integer in this for loop until it's converted into something that is iterable. Well, strings are iterable, so if we convert n into a string, we can then use this for loop on it. Once we use this for loop on it, I will be, for each iteration, an individual digit of that integer. If we take that I, or that individual digit, convert it back into an integer, and append it to our list, like so, well, once this for loop is done, we will have a list of digits. Say n is 942. We will have a list afterwards that looks like this, 942. Now we have a list of integers that is iterable that we can then pass to our sum function and sum it up. So let's do just that. We'll sum it up in a sum function. But if you think about this, what this is doing is this will return n if and only if n is less than or equal to 9, meaning it is a single digit integer. However, on the other hand, if this test condition is false, we're just going to return the sum of every digit in that integer. Well, this will work for two possible cases. If the integer n that they pass us is less than or equal to 9 from the get-go, or if it's a case like this where we only have to sum it up once. So if we print n and we actually test this out, let's just print it, and then we attempt it. As you can see, it worked for 16 because although 16 is not a single digit integer, when we sum up 1 plus 6, and that'll give us 7. So we only had to sum it up one time. However, it didn't work for 942. It returned 15 because if you sum up 9 plus 4 plus 2, one time. That'll give us 15 and it returned that. So how can we fix this so that this will sum up over and over and over again until this test condition is met? Well, what we could do is we could pass this entire thing, the summation of our digits, back to the original function to then be tested to see if it's less than or equal to 9. This is something called recursion. So if we could call the original function, we can say digital root, pass this entire thing as an argument to our original function. What this will do is, say n is 11. That is a multi-digit integer, so this else condition will be hit. It'll sum up 1 plus 1 is 2. 2 will then be passed back up to here, and then it'll check, okay, n is 2, that's less than or equal to 9, and we'll return it. And it will continuously pass the summation of our integer back to the digital root function until that integer is less than or equal to 9. So let's attempt it now. Oops, sorry. There you go. 110 test cases passed. So that is the digital root problem on Codewars, solved in a single line of code using recursion inside of a ternary operator. I hope that you found this interesting and you thought this solution was at least interesting. If you did, I would appreciate it if you liked, commented, and subscribed, and I will see you guys in future tutorials.